Before the introduction of indoor-outdoor cables, fiber optic cables could be divided in two categories, indoor and outdoor. The outdoor cables had black jackets and continue to have black jacket because of the UV protection required outside. The indoor cable on the other side have different colored jackets because of the different types of fibers used. Some examples are shown on this board. At the top we have the outside plant cables. In the middle we have the indoor-outdoor cables, and then on the lower half we have the indoor cables. As you can see, this are a colorful bunch. To distinguish between the various fiber types, OM1, OM2, OM3, OM4, and OS2, the cables are color-coded. Each fiber type is unique in its capacity to carry information. This capacity is also known as bandwidth. Of importance is the distance that each given fiber type can carry the information. Looking at the chart, one can see that the fiber performance increases from left to right. 62.5 micron or OM1 fiber has been around for a while. It can only carry serial 1 gigabit Ethernet for 300 meters at 850 nanometer wavelength and 550 meters at the 1300 nanometer wavelength. Likewise, Corning Cable System OM3 fiber can not only do the same for more than triple the distance at 850 nanometers, but can also carry 10 gigabit Ethernet at double the distance of OM1 fiber at 850 nanometers. Notice that the laser optimized fibers, Pretium 300 and 550 by Corning Cable Systems nomenclature, are optimized for 850 nanometer lasers. Single mode fiber or OS2 fiber has the advantage of high information carrying capacity, low attenuation, and low fiber cost. But multi-mode fiber has the advantage of low termination and electronic costs that may lead to lower system costs.